Okay, so here's a little pointer for questions that involve inequalities. Most of the time, especially if it's a system with inequalities, most of the time we can ignore the inequality symbol and just pretend that it's an equal sign. So let's just do it as if it said y equals 2x minus 1 and 2x equals 5. So I'm ignoring the inequalities. What would I do? Well, some of you are going to solve for x and get x is equal to 5 halves. We could do that, but we should also just notice, like, hey, 2x and 2x are in both of these. So I can make a little substitution without having to actually solve for x. That's a nice little thing that happens a lot on the SAT, where we have a habit of solving for every single letter, but sometimes we can get away with a little shortcut where we don't solve for the letter itself, we kind of solve for a grouping of things. And so this is a case where this grouping can just be substituted, right? So 2x, I can just say that y is equal to 5 minus 1 instead. And so then y is equal to 4. So are there any answers that kind of look like that? Yeah, B, and B is the answer. So why did that work? Well, it has to do with the way inequalities are and the way that SATs test them. Basically, when the SAT is testing inequalities, they're pretty much testing like the limit, the edge of the inequality, which is kind of where the equals is. So we can, for algebra reasons, pretend that we only care about the edge. We only care about the equals, at least temporarily. So that way we can do the algebra without that extra baggage of the inequality symbol. This is especially true when the inequality question involves things that say like, what is the maximum possible value of x, or what is the minimum possible value of y? Those are the kinds of cases too where we know that if we were to draw it, we would have some crazy like shading going on, right? We'd have an equation and we'd find an inequality that looks like this. But the limits of those inequalities are going to be things like where the intersection is. And that's kind of what's happening here as well. I don't really want to get more into it than that. This is the kind of case where you should just take my word for it. There will be exceptions where the inequality absolutely matters, but we can always add it back in by testing numbers and seeing if they work. Generally, on a question like number 6, where it's supposed to be on the relatively easy side, my advice is ignore the inequality, do the work as if it's an equals, see if it helps, and most of the time it will, and if not, just adapt. Put in some numbers, test them out, see what makes sense based on the equations you have. This is going to work most of the time, though.